Hi Andy, good morning. This is Dr. C.H. Kiran Kumar dealing you the machine learning part. Right, today we are in the Unit 3, last chapter, last concept called as descriptive rule learning. Descriptive rule learning, my dear friends. Descriptive rule learning. Right, what do you mean by descriptive? Descriptive. Now, initially in the first chapter itself, we learned what is called descriptive. Descriptive. Now, whether a model's output involves the target variable or not. If the target variable is involved, such is called predictive. Predictive. If the target variable is not involved in the output model, that is called descriptive. Descriptive. So there are many examples for that, right? Okay, right. Rule model. See, rule model is applied to regression and clustering tasks. Such one is called descriptive rule learning. Descriptive rule learning. Right. Now we are going to learn rule learning algorithms to subgroup discovery. What do you mean by subgroup? Subgroup, grouping. Subgroup discovery, right? Let us learn that subgroup discovery. Now, rule learning for subgroup discovery. When learning classification models, it is natural to look for rules that identify pure subsets. Hope you understand what I mean by pure. Pure, all belong to the same category. That is called pure. These are all called pure. This is pure. All belong to the same category, same class. That is called pure. Pure. Right. No, normally, so we identify from the training examples for pure subsets. Sets of examples that are all of the same class and that all satisfy the same conjunctive concept. So normally we look at that. A good subgroup is one. A good subgroup is one whose class distribution is significantly different from overall population. Overall population. So we have to, a good subgroup is one whose class distribution is significantly different from the overall population. So this is by definition true for pure subgroups, but these are not the only interesting ones, my dear friends. See, a good subgroup is one whose class distribution is significantly different from overall population. Now by this definition, we can see all pure subgroups are defined exactly correct. But we will see. So this is not always not true. See, we will see that. For example, if you consider what is the complement of a subgroup? What is the complement of a subgroup? In our dolphin example, if we consider the concept called as gills is equal to S, which covers 4 negatives, my dear friends, and no positives. Let us see that. Gills is equal to S. Right. See, gills is equal to S means we have covered N1, N2, N3, N4, and no positives. No positives. We covered only 4 negatives. So we can write this as 0 plus, comma, 4 minus. Right. So if we see gills is equal to S, right, if we see this, right, which covers 4 negatives, and no positives could be considered as interesting. What is the complement of this? Gills is equal to no. Definitely Gills is equal to yes. Complement is Gills is equal to no, which covers one negative and all positives. This means that we need to move away from impurity based evaluation measures. So we have to, previously we used to calculate impurity measures, my dear friends. Impurity measures. Now we have to go in a different way. See here, if I say Gills is equal to S, if I say Gills is equal to S, it is giving us 4 negatives, N1, N2, N3, N4, and N5. And if we say, what is the complement of this? The complement of that is Gills is equal to no, but which covers right. If you see Gills is equal to, when we say Gills is equal to S, we are able to cover N1, N2, N3, and N4. And if you consider the negation or complement of this, that is nothing but Gills is equal to no. And we say now there is only one negative, N5, and all positives, P1, P2, P3, P4, and P5. So now we have to think. No, previously we used to talk about impurity based evaluation measures. So we have to move away from this. We should think in a better manner. That is what we are going to do now. So this is what complement of a subgroup, right? Subgroups can be plotted. See, subgroups also can be plotted as points in a coverage space. See, this is what it is. This is y-axis. This is x-axis. See, normally negatives. And here we'll take positives. See, a subgroup also can be plotted as points in coverage space. See, with positives on the y-axis and negatives on the x-axis. Any subgroup plotted on ascending diagonal has the same portion of positives as the overall population. This is what it is. This is diagonal. This is diagonal. So this part is positives, more positives, and this part more negatives. Any subgroup plotted on the ascending diagonal has the same portion of positives as the overall position. See, population. Subgroups above the diagonal have a larger proportion of positives than population. See here, if you see here, subgroups below the diagonal, these all subgroups below the diagonal, below the diagonal have larger portion, my dear friends, larger portion of positives have a larger portion of positives than the population. See, very simple, let me tell you. So this area, so subgroups above the diagonal have a larger portion of positives than population. See, this subgroup diagonal shows you the average portion of positives. See, so clearly this portion consisting of subgroups which are having portion of positives. So larger portion of positives than the population. Definitely. So one way to measure the quality of subgroup is to measure the absolute deviation from the default value on the diagonal. So we are impurity measures we are now calculating the measure of absolute deviation, my dear friends. Absolute deviation from the default value on the diagonal. We are now calculating the absolute. Now we will see, we remove even absolute deviation. Absolute what is this? Right, we'll see what is it. Right. For example, you can see here the different subgroups are mentioned here, negatives with the positives. For example, the precision of any subgroup on the diagonal is equal to the portion of positives. So this leads to precision minus position as one possible quality measure. See, precision minus position is one quality measure. Precision minus positives is one quality measure. For reasons already discussed, it is often better to use Laplace corrected precision called as precision power L. Precision power L is called Laplace corrected precision, leading to the alternative measure called as absolute value of precision power L minus positives. Precision minus positives as one possible quality measure, and Laplace corrected precision measure is precision power L minus position. Now let us recall. Let us remember what we discussed, some measures of this purity or impurity in the chapter number 3. What are they? Recall for FPR and TPR. So FNR, false negativity rate, false positivity rate, true positivity rate, true negativity rate. So all these things now come under. Now here also subgroups on the diagonal always have average recall as 0.5. Subgroups on the diagonal. So on the diagonal will have recall as 0.5. This is recall as 0.5. Now, so a good subgroup evaluation measure would be average recall minus 0.5. Average recall minus 0.5. So we will see what is it. We will see how do we calculate the average recall and all, right? Subgroups on the diagonal always have average recall 0.5. There is no doubt, right? So a good subgroup evaluation measure is absolute value of average recall minus 0.5. Average recall minus 0.5. Average recall can be written as, my dear friends, average recall can be written as 1 plus TPR, true positivity rate, FPR, false positivity rate by 2. And thus, see, and thus we can calculate, we can come to a conclusion that FPR, average recall, minus 0.5 is equal to TPR minus FPR by 2. TPR minus FPR by 2, because 1 by 2, so 1 by 2 has, no, so modulus absolute value of TPR minus FPR by 2. This 1 by 2 can be neglected. So, right, average, see, this 1 by 2, this is average recall is written as 1 plus, see, average recall is, see here you can see, average recall is 1 by 2 plus TPR minus FPR by 2. Am I right? So now average recall, so if you minus average recall minus 1 by 2, that gives you 1 by 2 plus TPR minus FPR by 2 minus 1 by 2, this and this gets cancelled. So average recall, see, we are left with average recall minus 0.5 is equal to minus TPR, modulus of TPR minus FPR by 2. So now you see absolute value. If absolute value is not taken, if absolute is removed, absolute, what is the term absolute? Absolute ante అర్థం ఏంటండి? See, absolute of minus 5 is 5. Absolute of 5 is 5. Now, if absolute value is not taken, so that the signature of the difference tells us whether we are above or below the diagonal. See here, it specifies, no, these negatives or positive signs specify whether we are on the positive or negative, on the diagonal, positive lo unnava negative lo unnam kuda specify chestadi. So this is in this way so you can easily see if you remove the absolute, automatically by which we can easily say check whether our subgroup is on the above the diagonal or on the below side of the diagonal. A related subgroup evaluation measure is, see, we can see now a measure. Same. So one measure is average recall minus 0.5, that is nothing but total positivity rate minus false positivity rate by true positivity rate. True positive rate minus false positive rate by 2. True positive rate minus false positive rate by 2. Right? Another measure is, see, a related subgroup evaluation measure is weighted relative accuracy. Weighted relative accuracy. We have already seen what is called now average recall minus 0.5. This is subgroup evaluation measure. This is the first one. Average recall minus 0.5. And the second one is weighted relative accuracy. Weighted relative accuracy, which can be written as positive into negative and TPR, true positivity rate minus false positivity rate. So by using this weighted relative accuracy, no, the previous one is called Laplace, and this one is called, no, weighted relative accuracy. Now if we draw no, curves, coverage space. So it would look like this. This is Laplace corrected precision, and this is weighted relative accuracy. So definitely weighted relative accuracy is more no, reliable than Laplace corrected precision. Right, we'll see. Right, let us see the algorithm. Let us see the algorithm which, no, the weighted covering algorithm is given. This algorithm can be applied to discover subgroups over k by 2 classes. It is not used for true or false positive, true or false classes. It should have more than 2 classes, my dear friends. It should have more than 2 classes. Then only it is applied. It is applied. So as long as the evaluation measure is used to learn single rules, can handle more than 2 classes. See, let us learn this algorithm. First, labeled training data with instance weighted, weight initialized to 1. Weights, all instance weights initialized to 1. Now we will calculate the weight. We have to calculate the weight. So which are initialized normally to 1, my dear friends, 1, 1. Which are initialized to 1. Now rule list. We will create the rules list. Now initially we place empty to rules list. Empty to rules list. While some examples in D have weight 1. వేటికైతే weight 1 ఉంటుందో వాటిని ఒకదాన్ని తీసుకో. Now we apply the learned rule. Learned rule. It gives us learned rule D. D ni పంపిస్తాం. It gives us the best rule. The best rule. అది దేంట్లోకి ఇస్తుంది? R లోకి ఇస్తుంది. R will get it in R. We will append that R to R. Now decrease the weights of examples covered by R. Decrease. Now initially we thought 1 is the weight of this particular rule. So ఇప్పుడు ఏం చేస్తున్నాం? దేనికైతే weights ఇచ్చామో ఆ weights యొక్క 1 ని decrease చేస్తున్నాం. This is how average weighted covering algorithm. This is called weighted covering algorithm. My dear friends, learned rule is our formal algorithm only. Let us see what is this learned rule. We have already seen learned rule only in the rules list. We'll see again. This is our learned rule. This is our learned rule. Hope you understood. What is learned rule? Learned rule. This is our learned rule. First, D is the rule or output oka rule istam. B is equal to 2 తీసుకున్నాం. Set of all literals తీసుకున్నాం. Best literal తీసుకున్నాం. And దాన్ని B కి append చేసేసాం. R చేసాం. And చేసేసాం. True and true. True and literal gives you literal only. So దాన్ని దీంట్లో నుంచి తీసేసాం. మళ్ళీ దాంట్లో నుంచి లిటరల్స్ కూడా తీసేసాం. ఫైనల్ గా ఈ అన్ని ఇంకేమీ లేదు, అన్ని హోమోజీనియస్ అయిన తర్వాత we call this as labeled C అన్నా. లేబుల్ తీసుకున్నాం దాన్ని. So this is the final literal we are returning to the main function. This is the final literal we are returning to the main function. So that rule that is considered here, learned rule is applied here. We are going to get that rule and we are appending that rule to rule list and decrease the weight of that particular example covered by our weight ni decrease chesi. So unless all ones anni ones అయిపోయేదాకా this process is continued. This gives you weighted covering. This is called weighted covering algorithm. Hope you understood, my dear friends. In the next class we will see the other things. Thank you.